Hey, hi everyone. I'm Bhargav from Web3 Foundation, and today I'm going to be talking about trustless and efficient bridges. Uh, we introduce a new technique called random sampling, which lets us achieve this. This is joint work with Fatima Shirazi and Alistair Stewart, who are my colleagues at Web3 Foundation. So to start with, I would want to rebut one of the previous speakers' claim that trustless bridges are like holy grails and they do not exist. We have literally implemented this and is currently live. So let's get started. What are bridges? I guess most of you already know, but just to set the context, bridges are infrastructure for interoperability between independent and technically diverse chains, right? So blockchains are really good within the network, but they're not so good at following other networks. So here I have Polkadot and Ethereum, and both of them have the latest state or the state after a block gets finalized. And what I mean by a bridge protocol here is at the most general level, where the protocol allows you to fetch and believe the state of the other chain, right? And so this is kind of the base layer, and on top of this you can have interesting applications like swapping assets, migrating state, using the governance of one chain on the other, and so on, right? So traditionally, bridges have been built using trusted or centralized entities. And these are usually multi-sigs, right? So you have a trusted entity who sits between the two chains and is relaying the messages between the chains. But there are a lot of issues with this setup. One is safety issues. So basically, you are really trusting that the intermediary is not accepting invalid transactions, right? So something like an invalid transaction which was not finalized on the source chain is not being relayed. The other is liveness issues. Since this intermediary is a single point of failure, there can be DOS attacks or something to take this entity down, and then your bridge is not live. And the third is censorship. So the intermediary can be selective in relaying the messages or censoring messages if and when he wants to. So far, this is not going so good, right? I mean, a lot of bridges have been hacked. And there are studies which show that more than 50% of all the crypto hacks are related to bridges in terms of value. And this kind of drives the point that the security of a system is as good as its weakest link, and here bridges are the weak links. So what do we mean by trustless bridges, right? What are the requirements? In our setting, what we mean is we don't want to have any additional trust assumptions on the intermediaries or relayers for the safety of the bridge. Of course, we would depend on it for the liveness, but for the safety of the bridge, we have no honesty assumptions on the relayers. This means that running a relayer is permissionless and decentralized. Anyone can run a relayer, and you don't need to stake or be whitelisted to be a relayer. Second is the misbehavior. If something goes wrong in the bridge, you should be able to trace it back to the validators on the source chain, because they are the ones who are staked, right? So the classic don't shoot the messenger, but find the root cause of the issue. And finally, you need it to be efficient with really low latency to improve the user experience. And our approach is to build trustless bridges using light clients. So this is a generic approach, but I want to instantiate between Polkadot and Ethereum. So the way we do it is we run light client of one chain on the other, right? So here we are running a light client of Ethereum as a parachain on-chain on Polkadot, which listens to the finality of Ethereum's Altair sync committee protocol. And on the other hand, we are running a light client as a smart contract on Ethereum, which listens to the finality of Polkadot. And in the middle are these trustless relayers who are just relaying messages and collecting fees for the work that they do. And yeah, so the main challenge of running a light client smart contract is it's expensive, right? So the idea is how do you want to make it as efficient as possible? And here is where like Beefy comes in. It's a protocol where we add an additional layer of finality on Polkadot so that it makes it easier for on-chain light clients to follow it. And then we have like a interactive random sampling protocol, which reduces the cost while still like retaining the security. The protocol is like really intuitive. It's a classic commit, challenge, response protocol, and it's so intuitive that I tried to like convey it through a comic, right? So the idea is really simple. So once a block gets like finalized on Polkadot, there's a relayer who comes and like submits it on chain to a smart contract on Ethereum, and he claims that he has like the signatures of like 2n+1 validators. So Polkadot has 300 validators. So he claims that he has the signatures that 201 signed on it. And then the smart contract on Ethereum uses the randomness beacon to randomly select only a bunch of them to verify. The naive approach of like verifying all these 201 signatures would be very expensive on chain. So it randomly just selects a bunch of them. And then like the relayer like shows those signatures which the light client requested. Oops, sorry. Yeah, and if those signatures verify, then it's good to go, and like it updates its state on the latest Polkadot commitment. So we do like a thorough security analysis of this protocol. And the core idea is that we derive the security from slashing the validators on the source chain who signed unfinalized blocks. So that's like the core idea. And we have like a cryptoeconomic soundness result, which in principle, it states that in expectation, the adversary's incentive of launching an attack is negative. So the chances that he is going to get slashed, the validators are going to get slashed is in expectation much higher than the probability of successfully getting the randomness right. And the key security parameter here is the number of signatures that are being randomly sampled. You can learn more about it in our paper. I have linked like a QR code to the paper here. There are a bunch of like additional considerations like concurrency issues and the fact that the randomness beacon is biasable. So we do like a thorough analysis of like the bias and like quantify this bias and like describe ways to mitigate it. And yeah, finally, like here is like basically a comparison of our approach against Snark and like ZK-based approaches. And we are like competitive all the way up to like validator set sizes of 1 million. Yeah, finally, like this is not just theory. Like this protocol has been implemented in a bridge that is currently live between Polkadot and Ethereum. You can check out the app over here. And yeah, so to sum it up, like we build like a trustless and permissionless bridge, which is like very generic and supports arbitrary dApps, and back it up with robust cryptoeconomic security arguments. And we also have like a follow-up paper which uses Snark-based techniques to, yeah, which uses like aggregatable signatures to like even further reduce the latency. We have the paper on ePrint. Here's like the link to the paper. And yeah, here, like at Web3 Foundation, we have this like core philosophy, less trust, more truth. And this project is basically one step towards that direction. Thank you.
Thank you very much for that presentation. We may have time for one question. If not, we will roll on to the next presentation.